Hello and welcome to Maths by SAS. This is my ninth lesson of D4, chapter number 3, exercise 3C, that is about the multiplication law of probability, independent events and the conditional probability. In this class, students will be learning and discussing intermediate level question number 12, and let's first read and understand the question. Question 12 says, in the wardrobe there are 16 shirts, out of which 8 are black, 6 are white and 2 are blue. The shirts are identical except for their colors. Shirts are identical. Identical means that they are same, their texture is same, okay, their material is same except for the color. If two shirts are taken out of the wardrobe, find the probability that both the shirts are black. One shirt is black and the other is white. One shirt is black and other is white. Two shirts of the same color. If the third shirt is taken out from the wardrobe, calculate the probability that all three shirts are black. And then we have to decide, can we use the multiplication law of probability? We will be discussing about this in the last part. So let's move to the solution of the question. The question says that total shirts are, how many total shirts are there? Total shirts 16, of which number of white shirts, of which 8 are black. Number of black shirts, how many black shirts are? Total shirts are 16. Number of black shirts 16, of which 8 are black, 2 are blue, okay, 8 are black, 6 are white. Number of white shirts, I have to write properly. White shirts, how many are white? There are 6 white and 2 are blue. Number of blue shirts, okay, 8 and 6 14. There have to be 2, yes, there are 2 blue shirts, okay. Now the first part says, if the 2 shirts are taken out from the wardrobe, find the probability that both are black. So first part says that probability both black. We have to pick up how many shirts? We have to pick up, select 2 shirts, probability of black with black. Now try to understand the question, that the shirts that we are selecting, they are from the same wardrobe, they are from the same box. When we will pick up the first shirt of any color, the choices of the next shirt will be affected by that. So when I will be picking up the first black shirt, the choices are 8 out of how many? They are 16. Now when I will be picking up the second black shirt, here it's important to understand that the choice of the second shirt will be affected by the choice of the first shirt. Now we do not have 8 black shirts in the wardrobe, there are total 7, and total are 1 less than the actual total. So this will become 8 ones are and 8 twos are, and then it will become 7 by 30. I hope you are clear that how we are finding the probability of picking up a second black shirt, okay. Moving to the second part, one shirt is black and the other is white. Second part is one shirt is black, probability one shirt black and other white. Now wait here and try to understand the sentence. There is no restriction imposed. Either you can pick up the black first and then white, or you can pick up the white first and black later. There is no restriction imposed here. Probability of black with white plus or probability of white and black. Now when I am picking up black shirt, the choices are 8 by 16, 8 by 16. As I am picking up the shirts from the same box, same wardrobe, so total shirts will no more be same. There will be one less than the actual total, but the number of white shirts are not affected. Number of white shirts are not affected by the choice of black. Plus then white in the beginning, white 6 by 16 times 8 by 15, 8 by 15. And now it's the time to go for the simplification. If we can, 8 ones are, 8 twos are, they are not the large numbers. 2 ones are and 2 threes are, and 3 ones are and 3 fives are, 3 fives are. And same I hope we'll be getting for the other. 8 ones are, 8 twos are, 2 ones are, 2 threes are, 3 ones are and 3 fives are. So the simplified answer with me is 1 by 5 plus 1 by 5, which is equal to 2 by 5. 2 by 5. Okay, the two shirts of the same color, two shirts of the same color. So the probability that two shirts of same color, so it means that what choices I can make, that I can pick up, when if I am picking up black first, then I have to pick up the black as well, black with black, then white with white, probability of white with white, and probability of blue with blue, probability of blue with blue. Okay, let me make some because both have the same starting letters. This is black and blue. Okay, now the probability of the black, 8 by 16. When I picked up first shirt black, when I will be picking up the second shirt from the same wardrobe, from the same box, total will be one less than the actual total which is given in the question. And black shirts, one black shirt I've already picked up, so this will become 7. So the next is white with white. So the choices of white, total or the favorable chances of white are 6 by 16 multiplied by 5 by 15, and for the blue shirt 2 by 16 multiplied by 1 by 15. I hope you are clear about this, and it's the time to go for the simplification. As when I will be reducing these fractions to simplified form, to once I will not be getting the same denominator. So in the beginning I will prefer to keep the denominators as it is. This will become 16 times 15, 16 multiplied by 15. This is 240. So all the denominators 16 multiplied by 15, all the denominators 16 multiplied by, so this is 16 multiplied by 15, 240. 8 times 7 is 56, 6 times 5 is 30, and 2 times 1 is 2. Now I have to take the LCM. 240 is the LCM. So 56 plus 30 plus 2, so this will become 56 plus 30 plus 2, this is 88 by 240. 8 threes are, table of 8 11s are, and 8 threes are and zeros are, 11 by 30. 11 by 30. And now moving to the next part that says that if the third shirt is taken out from the wardrobe, calculate the probability that all three shirts are black. Probability of all three shirts black. All three shirts black. This is equal to probability of first black and second black and third black. So the chances of first black are 8 by 16. I have picked up one shirt here, so 7 by 15 multiplied by what? I have picked up the second shirt here, so 6 by 14. 6 by 14, all shirts are black. So 8 ones are and 8 twos are, 2 ones are and 2 threes are. So this will become 7 ones are, 7 twos are, 3 ones are and 3 fives are. 1 upon 5 times 2 is 10. 1 upon 10. So all shirts are black, are choices are 1 by 10. And now moving to the third part that says, can we use the multiplication law of probability to obtain the answer in B? Answer in B, if you look at the answer of B or the procedure of B, we can see the choice of the second shirt has been affected by the previous choice, and the choice of the third shirt has been affected by the choice of the next two previous two shirts. So for C part, these are not independent events. The selection of all three shirts is dependent. We cannot apply. No, we cannot apply. We cannot apply what? Multiplication law of probability. Multiplication law of probability because what is the reason? What is the reason? That the choice of or the selection of three shirts are dependent events. Of three shirts is not independent event. Not independent, or it's a dependent event. It is dependent event. I hope you are clear about this question, and let's move to the next question. Moving to question number 13. Let's read question number 13 first. Question 13 says 10 cards are marked with the letters PRO, POR, TIO and N respectively. These cards are placed in the box. 2 cards are drawn at random without replacement. Without replacement, here the term without replacement is really important. That what do we mean by without replacement? And then we have to calculate the probability that the first card bears letter O, the 2 cards bears the letter P and O in that order. 2 cards bear the letters P and O in any order, and the 2 cards bear the same letter. So let's try to understand the question. The question is about some cards, and they are written different letters like P, R, O, P, O, R, T, I, O and N. Okay, let's move to the understanding and solution of this question. As we need to find the probabilities, so probability formula for the probability is probability of any event equals to favorable chances upon total chances. Chances upon total chances So what we are going to do, first of all, we have to find that how many different letters are there. P, then R, then O, then T, then I. Okay, now I have to see that P is coming how many times. P one time, P second time. There are two chances for P. There are two chances for P. R is coming. R one time here, R one time here, it's two time, and O three time, 3 to 6 and to 8. T and I. T is coming once only and I is coming once only. Okay, and now total chances. Total 2 plus 2 4 plus 3 7, 1 8 and 1 9. Let me reconfirm this. P is coming two times, R1, R2, then O and N as well. We are leaving N is coming once only, and the total are 4 and 3 7 and 1 8 and 1 9 and 1 10. Now the first card bears the letter O. The first card bears the letter O, so the probability of letter O. First card bears the letter O. We have to see that how many chances favorable to O are with us. There are 3 chances out of how many chances? 10 chances. Okay, I hope you are clear about this. And moving to the second part, the two cards bear letter P and O in that order. So it's really important that we have to understand this restriction, this condition, that P and O in that order. So probability that P and O in that order, So it means that we can only pick up the chances P first and O later. And the chances of P are 2 by 10. 2 by 10, as we have picked up one card. So the choices of O will not be out of 10, they will be out of 9. But total chances of O are not affected, they will remain same. So 2 ones are and 2 fives are, 3 ones are and 3 threes are. So P and O in that order will have the total chances 1 by 15. Moving to the next part, the letter P and O in any order. P and O, try to understand the difference between these two parts. P and O in any order. In any order. Now, try to understand this, that there can be the chance that you can pick up P, letter P first and then O, or you can pick up the letter O first and P later. So for this situation, probabilities will be P and O plus probability of O and P. Now, if I'm picking up letter P out of 10 letters, then the choices are 2 by 10, and O are 3 by 9, which we already have done, 3 by 9 plus. Now, if I'm picking up letter O first, then choice of letter O is out of this total sample space. Now, if I'm picking up letter O from the total sample space, so the total choices for choice of letter O will be 10 multiplied by P. Now P has the choices 2 by 9. You can see that both the numerators are same, or what we can do is, and the denominators as well, 2 into 6 by 9, 2 into 6 by 9, but I'll do it later. Okay, 6 by 90, or what we can do is that 2 1s are and 2 45s are, 3 2s are and 3 15s are. So P and O in any order, the total choices are 2 by 15. It's up to you. Some of the students can do in this way and some can do like this is 6 by 90. I hope my working is visible. 6 by 90 plus 6 by 90. Now LCM is 90. 6 plus 6, which is equal to 12 by 90. And now it's the time to read the table, and table 6 2s are 12 and 15 6 are 2 by 15. In any case, we are reaching at the same stage. The first card bears the letter O. We have discussed this. P and O in that order, P and O in any order. The two cards bears the same letter. Fourth part is the two cards bear the same letter. Two cards bear the same letter. For this purpose, try to understand the situation that same letter means that if I am picking up the first letter with first card with letter P, the second will also be of letter P, or probability of RR or plus probability of OO. There will be no chance for T, I and N. And why there will be no chance over here for T, I and N? Because their cards are the single cards. So when I will be picking up first card, I can have the choice for the first card, but the second card, there is no second card having the letter T or I or N. So the possible outcomes will be P with P and R with R and O with O. Now when I am picking up P first, I will have the choice 2 by 10. For the second card having the same letter P, I picked up one of the card with letter P. So the second choice will be 1 by 9. Coming to R, again R has the same situation, that first time when I will be picking up first card bearing the letter O, having letter R, the choices will be 2 by 10. For the second it will be 1 by 9, and coming to O, O has 3 cards. So first selection will be out of any one of 3 cards, 3 by 10 multiplied by 2 by 9. Now in order to make your calculations easy, what we can do is, as the denominators are same, so I am not going for the cancellation, I am not going for the simplification at this stage. I will write the product as it is, and 2 multiplied by 1 is 2, then again 2 and 6, and then 2 plus 6 upon 90, 6 plus 2 is 8, plus 2 is 10 upon 90, 0 goes with 0 and 1 by 9. So the probability that the cards bear the same letter is 1 by 9. Students, I hope you are now clear about that how to understand what is conditional probability and how to identify the condition of the question. Okay, please watch and understand these all lessons properly during your summer break, because they are one of the important lessons of your O-level examinations. Please watch my lessons, like, share and subscribe the channel and press bell icon to get the notification of every lesson in time. Thank you very much.